Good evening, Taylor Tots. As promised, I owe you guys a video on thermodynamics. Being that your test is tomorrow, and congratulations, it's your last exam of the year. Now here's the thing. Obviously, you already notice from the very first thing that you are looking at that exo and endothermic is the very first thing I'm going to talk about. Now, here's the deal. Exo and endothermic reactions are two of the most important things that we've talked about this unit. If you go back to the notes, to the homeworks, to the quiz, I think it's very obvious how important exo and endothermic things are. So I just wanted to quickly peruse through them really quickly. I got a new friend today. Look at it. Look at it. It's the most glorious thing. Side note. Anyway. Now, here, let's get a look at this. Exothermic. Sorry for that side thing. I just love that thing, so I have to keep showing it off. Exothermic. Exo means that you are going to lose heat or you are going to lose energy. Now, because you are losing energy, we would say that it's negative because you are losing it. It is being released. And if it's being released in a chemical reaction, again, that it's going to be a product in your reaction. Now again, what this might look like is something like delta H equals negative 10 kilojoules, something like that. From the graph, again, your enthalpy value, because again, your reactants are going to be at some energy, your products are going to be underneath, we would say that that's a loss. And again, your curve for an exothermic reaction is going to look very decreased. It's going to drop underneath the reactants. Endothermic, kind of the opposite, you are going to be gaining heat or energy. And you are going to do this by absorbing it. Again, in this case, we're going to have a delta that's going to be absorbed because you're going to be taking in that energy, which means you need it before the reaction is going to start. And we could say that like delta H is like positive, let me just make that H a little bit better. The H will be like 15.2 joules. I'm just making something up. Other than that, if you look at the endothermic diagram, it's going to be an increase in energy, so your reactants are going to be underneath your products. And again, your activation energy, as you notice both times, is going to, oops, and actually, this is why I need to double and triple check things, and it's good. You know what, I just made a mistake, and that's a good thing. If you remember from that graph, it is a very common mistake. Like, I honestly just made it. It's a very common mistake to go from all the way to the bottom to the top for activation energy, okay? And I fully admit that I just did that. But the activation energy is going to be the reactants to the upmost part. How much energy did you need from the reactants to get this started? So, if your reactants are at 100, and this is 200, that would mean that this top value would be 100, 200, the top value would be 300. Again, very common mistake. You know what? I have no shame that I just made it too. I honestly just made it, and I've been doing this a lot longer than you guys have. So just watch out for that. This one's good. Again, reactants to the high point, reactants to the high point there. Now, that's a big thing. That's pretty much what you need to know about it. Other than that, we're going pretty good so far. Now, shifting gears just a little bit, okay? I've got one thing right here that I wanted to show you. Q equals MC delta T, and I'm going to zoom in just a little bit on it. Again, the math has been easy for you guys. You guys have been doing a great job with the math. The one thing that people have been getting wrong is the units. People are accidentally flipping C and Q. Again, C is going to be a heat unit, so it's going to be in joules or kilojoules. Again, negative is exo, positive is endo. A lot of people on the quiz, again, got that wrong. And it stinks because, yes, you got the answer right, but I have to take points off because you need to know if heat's going in and out of the system. C, the specific heat, that's going to be the one with the big unit, that joules per gram degree Celsius. And again, what specific heat is, how much energy does it take for you to raise the temperature of 1 gram of something 1 degree Celsius? So essentially, how much energy does it take to heat it up? Something like copper, you need very little energy. Something like a pot of water, you need a lot, which is why water is a very high specific heat. And again, delta T, Celsius or Kelvin, change of temperature, final minus initial. On the quiz, a lot of you did the big number minus a small number. But in that equation, it was going from 14 to 5, so it was cooling. If you have a positive temperature change, you're saying it's heating up, but it's cooling down. So again, that's where a lot of people lost both the points, but had the right answer. So you've got to be careful with that. Again, math is going very well. We'll do a quick little example problem with that, and we'll go from there. Now, the other thing that I do want to quickly mention is Le Chatelier's principle. Now, with Le Chatelier's principle, I'm just going to zoom out. With Le Chatelier's principle, again, all you're looking to do is you're looking to invoke a change in a system. Reactions don't like to be stressed out, okay? Trust me, I know. Maria, you were just doing your big school doctorate stuff. Were you stressed out that week?
Yes.
Do you like being stressed out?
No.
What are you going to do when you're stressed out?
Sleep.
Sleep or?
Watch Netflix.
Watch Netflix. And again, that's her saying it. What did I tell you she'd say? I told you in class that's what she would say. Okay, she is currently right now watching Degrassi. She's chilling like a villain. Now, we're going to do things as humans to de-stress. Reactions are the same thing. So let's get a look at this problem. Now, I'm doing one of each, but again, everything holds true for everything. Adding C. If you add C, that is not a good thing for your reaction. So essentially, if you're at equal levels, now you're going up from here. If I go this way with my reaction, more reactants are going to make more products. And as you see, if I'm going up, and I know I'm above the screen now, but that's not going to work. It's not going to help fix the system. But if I go this way, now I'm going to use up some of that extra reactants, and I'm going to get back down. So when you increase something, your reaction is going to go the opposite way to compensate for that. Because you have more stuff. Again, if I give you more Legos, you can make more things. If I give you more products, I can make more reactants. So you're going to shift toward the reactants the opposite way. Now, if I'm removing B, if I lose B, well, you don't want to lose stuff. If you lose stuff, you got to go that way to compensate. Again, I just lost B. If you just lost $100, aren't you going to do everything to try to get back your $100? Or if you lose, you know, a bracelet, or if you lose, you know, your good pair of running shoes or something, aren't you going to try to find them? Yeah. If you lose B, or if you lose anything else, you're going to shift that way to compensate. I need to make more. Reactions don't like losing stuff. So again, with this, you're going to go down. If I go this way, I'm going to keep going down. But if I go this way, I'm going to catch back up. And that works really, really well. And then the last question, which is the tougher one I put here, what if I put it into an oven? Now, if I put it into an oven, I'm going to be heating it up. Well, here's the thing. I have a positive heat value here. So is this endo or exothermic? Hey, you over there with the face. If this is a positive enthalpy value, it's positive 30.2 kilojoules. Is this an endo or exothermic reaction?
Endo.
Endo. Why?
Positive.
It's positive. It's gaining heat. It's positive. See, and she's not even, she hates science. She loves just sitting there and doing the math. So this is positive, it's endo, and if it's endo, is the heat going to be on the left or right side of the reaction?
Left.
Left. Very good. See, this isn't that bad. She can get it. It's going to be on the left side of the reaction. So I'm going to do my delta over there, which is really, really sweet. And if you're going to be putting the heat over there, and I'm putting it into the oven, this is going to go up. And again, if this is going to go up, you're going to go the opposite way to shift it over. So this one is going to end up going this way. Now, it's all about de-stressing yourself, you know what I mean? Don't worry about the pressure ones. I'm going to go from there. But with this, please keep in mind, it is important to know that if you're losing something, you're going to go towards that loss to try to fix it. And if you have too much, you're going to go the opposite way so you can use it. If you really think about it, it's very applicable to your real world, into your real life, which is a really, really cool thing with it. You know, really cool question. And honestly, that's been, you know, a pretty good start. I just reviewed a large chunk of the unit. But the thing that got people is, from the lab, it is clear that even though you guys did a good job with the lab, people are still struggling on this. Now I'm going to zoom back out so you can actually see, so I apologize if it's a little small, but I will write things a little, actually here, let me zoom in just a little bit. I think I can afford to zoom in just a tad. Okay, we'll try that. Here's going to be our problem. And I know it's really challenging to see. However, we're going to try to find the delta H of solution of NaCl dissolving in water. We can't measure that heat change or that temperature change, so we can't really do Q because I'm saying delta T, because you can't measure the temperature of something that's dissolving. There's no way. All you can measure is the temperature of the water that it was dissolving in. But we know, and this is a really cool thing, we know that whatever the Q of the water is, it's the opposite of the Q, or the heat, of the NaCl. If the water is absorbing, well, that means the salt is releasing. If the water is releasing, this one is absorbing. So it's a yin and yang kind of thing, which works really nice, but that means we have to find water first. Now, how would we do this? Well, as it's not too bad, we would, and again, I'm just going to make sure that everything's big enough so far. Okay, I'm just going to pick it up just a little bit. I'll make sure everyone can see all the work, so you guys know how much I like that. I'm just going to focus on this part. So, here's the thing. We're going to do water in green, and we're going to do the NaCl in blue. Okay, so we'll color code, So, what we've got going here, we've got our Q is, we've got 100 grams of water. The specific heat of water is 4.184. You would be given that information. And we know that the delta T, it went from 15 to 12. Well, that's going to be 12 is our T final. 15 is our T initial. So it's going to be 12 minus 15. That is -3, which tells you that the water is exothermic. That's really powerful information. So, if we end up doing this, Q is going to end up being a negative number, and let's see what that number is. So, handy dandy phone calculator. Let us see what's going on here. And again, I don't know if you guys can see this or not, but I'm just going to plug it in. 100 times 4.184 times -3. Oop, I want to restart that. 4.184 times 100 times -3. -3 negative times 100 times 4.184. I'm sorry, as you can tell, I'm not the best with using this phone calculator. -12,000, 1,255.2, and in this case, because the unit is joules, this is in joules. Cool. Now, what this means, this is all for water. And I'm going to pause for a second, just so people can kind of look, pause the video, do whatever you need to do. I'm going to zoom in on that a little bit more, too. We can zoom in a little bit more. Again, this is a dot right there. Okay, so now we know that the Q of NaCl, if that's negative, that means that this is a positive 1255.2 joules. All we have to do now is put that into delta H of solution, Q divided by mole. I know that that's positive 1255.2. I know that we have, according to this, I did give you 25.1 grams. I know the mass of salt is 58.5 grams per mole. And all you need to do is solve for that. And I know I'm writing really small because I ran out of space, but I will get you that. Times 1 negative. Divided by, and this is where my phone's, I think, going to be a little bad. So I'm going to try this. And then we'll do 25.1 divided by 58.5 is point. So the moles equals 0.429. So again, 1255.2 divided by 0.429. We are going to get a delta H of solution to be a positive 2,925.9 joules, or some of you are going to say 2.93 kilojoules. Again, positive. That is really good information to know. And again, I apologize, I know. Oh, I even shifted off. Sorry. So again, with that, it's going to be a little bit better. Again, I got the 25.1 because I would have given it to you. I knew everything else. And this is going to be how you would solve that problem. Again, all I did was I just had to find the moles. Again, I gave you the grams up there. And then you already have the Q, because it's the opposite of the water. And again, joules or kilojoules, either one. That works. And that's really all there is to this unit. I mean, it's the last unit, not too bad. I think you guys are ready to go on this. I know it might seem scary. Ooh, scary. Look at it. But other than that, it's going to be pretty good. Now, a few other quick things. I will tell you that I am going to have to make changes with the retakes this week and some other changes. Now, I will definitely figure it out. I kind of already know what I'm going to do, but I'm going to tell people in class. However, just so you know as well, if you want to do and help me with these YouTube videos next year for community service hours, essentially I'm going to have a little form that I'd like people to fill out for tomorrow. And I'm looking between 7 to 10 people. I would like to have a variety of people. Maybe some people feel they can help better with the math, and some people can do some explaining, and some people are good with diagrams, and some people are really good with Unit 1 or 2. So I do want to get a massive chunk in there. I do want to have you guys involved. So again, please let me know and see kind of how things are going. Now, being that this is the last video, technically before finals, I will get all that information out as well, and we'll try to go from there. So here's my little goofy face pillow. Go from there. Special guest star over there. Say peace road, bro.
Peace road, bro.
Peace road, bro. Later. Awkward ending.